Okay, so for example 2, we're going to look at, from a deck of 52 cards, what is the probability of selecting 4 aces in a row? We're going to look at this situation under two different examples. First, we're going to look at it as what's the probability of selecting those 4 aces in a row if you replace each card after you take it out of the deck. Then we're going to look at it, that probability if you select 4 aces and you do not replace each card as you select it from the deck. So, to start this situation, first we're going to have to identify what's the probability of selecting just an ace right now of a standard deck of cards. So, in the standard deck of cards, we have 4 aces, so that probability is for 50 seconds. So we're going to essentially create a decision chart here, similar to the way we worked in the counting principle. So we need to make identify one probability for each card selection under the assumption that we're replacing the cards. So for our first selected card, the probability of drawing an ace in that scenario is there's 4 aces out of a total of 52 cards. Now we're going to take that card, place it back in the deck, and pull another card out. So the sample space is still 52, and it's still the probability of selecting an ace. So since you pulled that card and placed it back in, there's still 52 cards in the deck and still 4 aces in the deck. So that probability is for 50 seconds. You place that card back in the deck now and draw your third card. So there's still 52 cards in the deck. There's still 4 aces in the deck. So for the third card, the probability is for 50 seconds. And lastly, after you place that card back in the deck and you go to draw your fourth card, there's still 52 cards in the deck and there's still 4 aces in the deck. So in this scenario, it's your first card, followed by your second card, followed by your third card, followed by your fourth card. So this is a multiplication of those 4 individual probabilities. Again, it's a lot easier in this situation if you simplify these first. If you choose not to simplify and place this calculation into your calculator, chances are sometimes the numbers get really large and your calculator automatically converts to scientific notation. And it causes some major problems for you in the end. So it's best to just simplify each individual probability. So 450 seconds becomes 1/13 for the first card. The second card becomes 1/13. The third card becomes 1/13. And the fourth card becomes 1/13. And then we multiply these 4 together. So you're multiplying straight across. So 1 times 1 times 1 times 1 is 1. And 13 times 13 times 13 times 13 is 28,561. And that is your probability for selecting 4 aces in a row without replacement. Next, we're going to work through the same scenario. However, we're going to calculate the probability of selecting 4 aces in a row without replacing the cards. So after you draw each card, you don't put it back in the deck, and the overall size of the deck decreases by 1 each time. So for our first card, we're looking at the probability of selecting an ace. So in that case, there are 4 aces in the deck, 52 cards in the deck, so that probability is 4 out of 52. Then we do not replace that card, so then we go to draw our second card. Now this is where things change. For your first probability here, we make an assumption that that card was an ace. So when we move to our second card, there's technically 3 aces left in the deck because you're not replacing it. And there's also only 51 cards in the deck. So the probability of drawing your second ace now is there's 3 aces left in the deck and there's only 51 cards remaining in the deck. So you've selected your second card and that card is not being replaced in the deck either. So when you move to your third ace or your third card, there's now only 2 aces remaining in the deck and a total of 50 cards remaining in the deck. So this probability would be 2 aces remaining in the deck out of a total of 50 cards remaining in the deck. And then for your fourth card, we're left with only 1 ace in the deck, assuming that we pulled an ace for the first 3 cards. And then your total size of your deck now decreases to 49. Again, in this scenario, it's much easier to simplify the fractions first before you go and do your calculation. And that way you don't have this extremely large numerator and denominator that you have to work through and simplify. So 4 50-seconds is going to simplify to 1/13 times 3 51sts, and that simplifies to 1/17 times 2 50ths, and that simplifies to 1/25, and lastly would be 1/49. We're going to take the product of these 4 fractions, and that's going to give us 1 over 270,725. So this is a probability of selecting 4 aces in a row without replacing the cards.